So let's start with storing data. We want to send a HTTP request when we hit that save button and we successfully validated our form and submitted it. So we want to send a HTTP request to this backend, to this URL here in the end, or to a URL that's based on that to be precise. And for that, let's first of all dive in our code. Let's go to the place where we do create a new product, and that's of course the Added Product screen. There, in the end, once we submitted our form, what happens is that we call add product here. Now we have two different approaches on how to send that HTTP request. We can send it here, so next to add product, either before we added the product or after we added it. And depending on how we control this, it does not make a difference, or it does make one. More on that in a second. But the alternative place to sending this is that we don't send it here, which is inside of a widget. Remember that, we're inside of a widget here, inside of a widget class, so that we don't have all the HTTP code here in the widget, but have it somewhere else. Because you might remember that earlier in the course I mentioned that it's always a good idea to move logic out of your widget. You want to have a relatively lean widget which focuses mostly on building the widget tree and then has some logic for managing its UI and the data you work with in your UI. All the heavy lifting of manipulating data, storing data, and sending data to a backend is typically not something you want to do inside of a widget. Instead, we could do it inside of our provider, actually inside of the add product method in the product start file, therefore. So here in the products class, which we use to manage the products of our app, we could also make sure that we send the HTTP request that saves that data on the server. So we still also manage it locally, of course, because we need that local list of products in our app. We want to have that data we work with in our app. We need to fetch it from a server and then manage it in our app at some point. But besides managing it locally, I also want to send a snapshot to the server when we add a product, so that in the future when our app launches or whatever, we can load our data from there. That's the idea. So therefore here is a much better place to send HTTP requests. And that's therefore what I will do. For this, here in the product start file, I'll import this HTTP package which we installed. So from the HTTP package here, I'll import the HTTP Dart file, and I'll actually import this as HTTP, so I'll use a prefix here. You don't have to do that, but since this exposes a lot of methods and variables and stuff, I want to avoid name clashes, and therefore I bundle this all on this HTTP prefix, which ensures that we never run into any name clashes, because we always access the features from this package now with HTTP dot. So with that imported, we can now start using features from that package. And again, we'll do that here in add product. Now I mentioned that it might or might not make a difference on whether we first run our HTTP code and then change our data locally and notify listeners, or if we do it the other way around. And the reason for that making a difference simply is that HTTP requests take some time to finish, because we need to send something to a server, the server needs to do its job and send back a response. That's how web requests work. Now, during that time, whilst we wait for the response, our app execution doesn't stop. Our app doesn't freeze. And that's good. It would be bad if it would. So therefore, the code, when we send a HTTP request, by default doesn't wait for this request to complete unless we tell it to wait. And I will show you both options here. But first of all, let's send an HTTP request. For this, we need a URL. So we can create a const here actually, because the URL will not change at runtime, which should hold a string. And this is basically this URL, but now Firebase, and that's really just Firebase, not HTTP requests in general, works such that you can specify any extra segment here, like products, which you essentially want to create as a folder or as a collection in the database here. Now that's really just Firebase. Behind the scenes, it reads that URL when it gets a request sent to that URL and translates this into a database query, which creates such a collection and stores the data there. Other APIs which you might be using might have clearly predefined endpoints to which you send requests, and there you might not have the freedom of adding any segment you want. So this is really a Firebase thing and related to how Firebase works, but here you can send this to products or prods or whatever you want, and it will create a database collection for that. And another Firebase specialty is that you have to add .json here at the end. Again, this is not a general backend request thing. Most APIs will not require this. It's just that Firebase requires this when it parses your incoming request. So the way or the exact endpoint we send here depends on Firebase. And of course, you'll learn such things from the official Firebase docs for its REST API. Other APIs you might be using might work different. The idea that you send requests with a certain verb to a certain endpoint is always the same though. So this is our URL to which we send the request. And now here, since I want to append data, Firebase offers us to send a post request. We do this by using the HTTP package, which I prefixed with HTTP. So we use HTTP dot here to access the features from that package. And there you'll find a post method or a post function. This sends a post request to the URL which you have to specify as an argument. So here I have my URL const, I pass this to post, and it will send a post request to that URL. Now a post request, however, doesn't just need a URL, you also need to define what kind of data you want to send there, right? Because the URL alone doesn't say anything about which data you want to store. Therefore, post takes a couple of named arguments. For example, you could also configure the headers. Headers basically are metadata which you can attach to your HTTP requests. We don't need that here, but if you're a bit more advanced and you know how to work with these and you have an API where you need to set special headers, you can do this with headers. Here, important for us is the body named argument, because this allows us to define the request body, which is the data that gets attached to the request. And now here for the body, we should use JSON data. JSON, written like this, stands for JavaScript Object Notation. Now we'll not write JavaScript code here, no worries. But this is a data format, just like HTML is one, or like normal plain text is one. It's a format for storing and transmitting data, you could say. It's a format that's particularly well readable by machines, and therefore it's the de facto standard format for exchanging data with web servers. So here we need to attach the data we want to send in JSON format. The data we want to send, of course, is our product, and if I would add product like this, it would not work, despite us not getting an error here. We would later get one, because this is an object in Dart, and that's not at all convertible to JSON like this. At least it won't automatically convert. Instead, you can create JSON, or you can convert it to JSON. For this, let's first of all import something from Dart, so a core library baked into Dart, and that's the convert library. This offers tools for converting data, and here we need to convert data into JSON. We do this by calling JSON, which is now an object or a class, a feature made available by that Dart convert library, JSON encode. Now this takes some data which we will now convert to JSON. We still can't pass our product object here, but we can pass a map because it knows how to convert maps to JSON. So we can simply create a map here with a title key which holds product.title, with a description key which holds product.description, with an image URL key which unsurprisingly holds our product image URL, and with a price key which holds our product.price key. And last but not least, also is favorite, which should hold product.isFavorite. For now, I will also store it like this on the server. Later, in a separate module, once we added users, we'll store this differently on a per user basis. So now this will send a post request to this URL with this JSON data attached. So this will be converted to this JSON format, and in the end, we send this piece of data to our server and store it there. Now, if we do it like that, let's see whether that works. If I enter test here, 1299, this is a test, and now I pick an image, like I did earlier in the course. If I now save this, you see this gets added here. And if you now go to your Firebase web console, here you should see a products node. There you see this cryptic string, which was auto-generated by Firebase, as I can tell you. And if you expand this, you see the data you submitted. So this now was stored on the server. But actually, it's important to understand how this works. Because even though we didn't see it here, actually we did not wait for this HTTP request to complete to add our product here to our in-memory data, or to our in-memory list of products. And one problem of that approach is that we still have our own ID here, whereas it would be much nicer to use this auto-generated ID Firebase gives us here, this cryptic string here. That would be much nicer to use. Now for that, however, we have to wait for this HTTP request to finish, and that's not the default behavior of Dart.